I see my little DEF CON 5 clock has already started. Here we go. Thanks for sharing some of your Friday with us. Welcome to the last day of Build. I hope you've enjoyed your lunch. My name is Charles Cox. I'm a program manager in Microsoft's Advanced Technology Group, or ATG. Our mission is developer support, making sure that people who want to build great entertainment experiences can do that and get the support they need across all of our platforms. Windows, Xbox, Windows Phone. I'm here to teach you a little bit about building a game for the Windows Phone platform. You've learned a lot about Windows 8, your brains are full, you've got your tablets. There's nice dark spaces that are scattered around in case anybody wants to go to sleep. I know it's been a long conference. But I'm hoping that we can jump in, do something kind of fun, a little bit different, and get a chance to talk about just getting into games development for Windows Phone. Lots of folks have questions. How do I do it? What are the frameworks available? What about Xbox Live? We're going to go through all of that. And we're going to stay focused on the Windows Phone development ecosystem, which is growing, which is powerful, which has a lot to offer games developers. And even if you're a traditional apps developer, there's still a lot that you can take away, and hopefully it can get you jumping into making games right away. And we're going to do that together right on stage. So now that I've told you what I'm going to tell you, let me tell you what I'm going to tell you again. They make me put up an agenda slide. It's really important. So let's talk about the Windows Phone game development story all up. Then we'll build a game with one of the development frameworks available to you on Windows Phone, XNA Game Studio. We'll walk through the APIs available and talk about each section, graphics, audio, input, math, how you can access the various capabilities of XNA Game Studio to build a game. Then we'll talk about the next version of Windows Phone. We call it Mango, Windows Phone OS 7.5, the differences that are available in Windows Phone Mango specifically for game developers. We'll show you a little bit of that transition and some of the cool stuff you can do with it. And then the section sort of mysteriously entitled What Now?, which is about your marketplace opportunities, getting onto Xbox Live if you're interested in the Registered Developer Program, and where you can go for more support, including samples, white papers, tutorials, and that kind of thing. You will leave this room with examples of how to use XNA Game Studio to build a game and integrate XNA and Silverlight together in Mango. Windows Phone game developer story. There are three big reasons to consider Windows Phone for your game development platform. If you build games, you want to know, why do I care? Why do I want to go over to Windows Phone? There are three huge reasons. One, powerful hardware. Two, premium gaming features that aren't found on any of the other phone systems. And three, accelerated development with XNA Game Studio or Silverlight. Let's dive in a little bit deeper into each of these and understand what they mean. When I say powerful hardware, there are two versions of the chassis, one now and one on the horizon, that we talk about when we talk about the hardware. The first chassis, November 2010 was the launch date, Windows Phone OS 7.0. The stats are there on the screen, you can see them. A 1 gigahertz CPU, D3D11 API-enabled GPU, and then the full sensor suite. So we're talking about the ability to develop 2D, 3D games with full hardware acceleration. And this chassis spec was fairly strict. This is a good thing for developers. By having a fairly strict chassis spec, it means that you can develop and lower your compatibility testing cost. You can be assured that the OS 7.0 chassis is fairly consistent across all manufacturers, so that you can build once and have a game that runs on all Chassis 1 devices. Now, with Mango, there's a V2 chassis spec. There are some changes coming. The V2 chassis can contain an optional gyro, which can be accessed with the new integrated Motion API available in Mango. And also, there's a change to the CPU specification. Instead of a 1 gigahertz, there's an 800 megahertz or higher specification. So there's a little bit of work you may need to do for performance, but as we move forward, those are the specs you can look at. Otherwise, they're the same as Windows Phone OS 7.0. Now, I'm just going to dial back for a second. I just got a fortune cookie at lunch that said, haste does not ensure success. So I walked up here really slowly. And I want to make sure that folks who are at this talk understand, because a friend of mine was very clear. He says, hey, be sure you're telling people that games are really big. Okay, I'm telling you, games are really big. I think you already know that. You know the opportunity is here. You know that games are an important piece of the entire app ecosystem for mobile, for PC, for Xbox 360. Folks get it. But I wanted to make sure that I said it, because that's the value proposition we're talking about. Now I'll continue. Speaking of gaming, Windows Phone offers something that competing platforms don't. Xbox Live games with premium gaming features. Any Xbox Live subscribers in the audience? Yeah. All right. Yeah. That was awesome. Oops, I am too. I forgot to raise my hand. I love Xbox Live, and I know a lot of you do as well. And the same great things that make up the Xbox Live experience in Xbox 360 are available on Windows Phone. Achievements and leaderboards. If you get gamer score on these Xbox Live games on Windows Phone, it applies to your Xbox 360. The whole thing is shared. Avatars and awards. Earlier this year, we announced Avatar awardables for Windows Phone. So you can actually have games in which an avatar will get an awardable from your game that shows up, a hat or gloves or earrings or whatever. Your game can award those as part of its gameplay now. Downloadable content. This sets off a light bulb in a lot of people's minds. Again, earlier this year, we announced our first game, Beards and Beaks, which uses a premium downloadable content. So both consumable content and durable content bought using Microsoft points. So now you can have your games that have these consumable transactions and charge per download and that sort of thing. So these sort of social mobile experiences are being lit up on Windows Phone through Xbox Live. And finally, if you've played games like Full House Poker, or I think Fable Coin Golf is another example, there's a cross-platform opportunity. You can develop games for Windows Phone and for Xbox 360 through the Xbox Live Arcade program, and you can share not just achievements and leaderboards and gamer score, but you can also share in-game data such as XP, levels, money balance, that kind of thing, and enable a very rich cross-platform scenario through Xbox Live. Now, I did light up here that it says for registered developers. Yes, that's true. It is a registered program. Entrance is limited. But near the end of this talk, I'm going to chat with you a little bit about an opportunity to get in the door at Xbox Live, even if you don't have a publisher. Microsoft Studios has an opportunity that might interest you, so we'll get to that near the end. But there's plenty of opportunity for you to get into the premium space. And I know you've got great ideas and great talent, so we want to help you make it happen. Okay, the third pillar of Windows Phone game development experience is this accelerated development. And what do we mean by that? So development on the Windows Phone ecosystem is one of two frameworks. Either you can go with Silverlight XAML, and this is an event-driven, control-style application where you have a design surface and you have code behind in C# or VB. So for those that are making apps and understand that model and the XAML model, this is very familiar. You lay out your surfaces, you code behind, you can make games that way. It's totally possible. The second way is XNA Game Studio. Now this is not a design surface. This is pure code. You have a buffer to draw to, and you just draw like heck to it. You got update and draw loops that are called once 30 times a second, and you make your game run in that environment. Code, and it's up to you how you want to draw and interact with the game objects. Both use C# or VB.NET and Visual Studio 2010. Now in the Mango framework, Silverlight and XNA can live and play and render together in harmony. And we're going to actually, hey, all right, that's great. You never know what's going to get the applause. I love this. Thank you. XNA and Silverlight have interoperability. Now, for those that have played in the XNA Game Studio 4 and Windows Phone space before, there was a lot that you still could do if you were a Silverlight developer. You could call the XNA audio APIs, the input APIs were shared, and so on, but you could never render together. Now you can, and we will talk about that. I'll even show you some code about how it's possible. It's very cool stuff. But just as we dive in and explore what it means to develop a game through using these APIs, we're going to use XNA Game Studio, and that's going to be our point of focus for the next 20 or 30 minutes or however long it takes me to build this crazy little game. And our feeling is, for Windows Phone, our experience has shown that XNA Game Studio should be your heavy lifter. when you're using 2D or 3D graphics, you should be considering XNA Game Studio for real-time graphics applications, and we will go in a little bit as to why. And there are reasons to use Silverlight as well, but what we'll do, we'll dive into XNA Game Studio and use that as our base. So what is XNA Game Studio? For those that haven't used it before, a quick primer. XNA Game Studio is both a framework and a set of extensions into Visual Studio that simplify the game development experience. The two major components are the XNA Framework, which is a set of APIs that work across Windows, Xbox 360, and Windows Phone, and the XNA Content Pipeline, which is a set of build-time extensions for Visual Studio that simplify and linearize the content building process for all your art and sound and data into runtime formats that then can be consumed by the XNA Framework. So there's your two pieces, and we'll go over them both. Let's start with the API. The XNA Framework is the API, and it's exposed to you through a set of templates in Visual Studio. The templates set up what we call the XNA application model. On the screen, you'll see that application model. It's pretty familiar to anybody who's built a game before. It really abstracts the game loop into these fundamental concepts. You have these functions: initialize, load content, update, draw, and unload content. Those are your entry points, and all you have to do is add your game code into the appropriate places. Now, what goes where? Initialize is called first. Initialize is called before a graphics device is set up. This is a place where you can do any loading that's non-graphics related. So you can set up your input buffers, you can do any non-graphics loading that you need to do. Load content is the first time a graphics device is available to you. At this point, you should start loading up your graphical content. 2D, 3D assets. You should probably also load anything fairly large in here as well, so sound effects, music. If you have XML data files you want to load, load content gives you the opportunity to do that. Then the heart of your game is instantiated. What happens after load content is that the XNA Framework will then move to update and draw, and it will loop these together at a rate of 30 times a second. They are locked on the same thread. If update takes too long, the draw call will be dropped in order to maintain update, and they will continue to run, again, at a target rate of 30 frames per second, and you simply plug in your code. In update, you're going to plug in anything that's non-drawing related. If you're going to be moving objects around, collision, AI, networking, pathfinding, input, that all goes in update. Draw, this is where you draw to the screen. A clear command clears out the buffer, and you have access to that buffer, and you can party down. There's a whole bunch of APIs to give you access, very fast access to the buffer. We'll talk about those soon. And then finally, when you get to the very end of the program, unload content is called. If you have any very, very confusing or complicated references that you need to untangle and get rid of, now is your chance. Though anything loaded through the Content Manager is handled quite gracefully, and we can talk a little bit about that as well when we move into the XNA Content Pipeline, the second piece of the XNA sort of ecosystem. The XNA Content Pipeline is a set of extensions that are integrated into the Visual Studio 2010 build process. It supports incremental building of your content separate from the game code. And what does this mean? I'll show you a demo in a minute, but what it essentially means is you have, inside of any XNA Game Studio project, a separate content project. Inside that content project, you just dump your stuff. Here's my JPEG files, my PNGs, here's some mesh files, here's my sound files, here's XML data. That stuff is all built by the XNA Content Pipeline when you press F5 and built separately from your code. Any changes that you make will be built incrementally, and any code changes that you make don't affect the content pipeline. This means that you can keep the art time or design time versions of your content separate from the runtime versions. This is great for a whole bunch of reasons. It simplifies your art process, leaves your artists free to work in whatever environment they like and outputting to a directory that's convenient for them. And it keeps the loading and conversion of design time to runtime formats away from your user. You, as the developer on your build machine, take that hit for the benefit of your customer. What happens is these files end up getting plumbed into the XAP that makes up your Windows Phone project in a runtime format that's already readable at runtime by the XNA framework. That conversion cost is gone. It doesn't apply to your user. This is a good thing. The XNA content pipeline has built-in support for many of the standard types that you'd use. In 2D format, it automatically eats and converts BMPs, PNGs, JPGs, TIFs, TGAs. Okay, I ran out. In the 3D world, support for the FBX and .x mesh standards are already inside the content pipeline. It eats and processes WAV files, MP3s, WMAs, and it supports XML in a special format for data. So serialization of data both in and out is supported. So in addition to that, a lot of you, if you are a game studio already, have an in-house format that you are very keen on. So if you have, let's say, OGG Vorbis audio files or mesh standards that you like, or your textures are compressed and packed in special ways, the content pipeline is fully extensible. You can write extensions to both the importers that pull in the files and the processors that act on these files to support your custom types. Completely extensible. All right, those are the two pieces. Let's talk about what you can actually do with the XNA framework. Why don't we start with the most basic case? I have a blank screen. I don't like a blank screen. There needs to be something on the screen. Why don't I draw something on the screen? That's the simplest case. I love doing this because it makes me feel like I'm actually getting somewhere when I have something on the screen. So we're going to draw a very, very cool, sort of a golden steampunky ship on the screen. I love this. I totally didn't make this. This is an artist. I can't draw. But I can take something an artist gave me and put it on the screen. And this is how fast it is. The two methods that you interface with are load content and draw. In the load content call, you simply call content, which is the content manager, .load, and it's a template function, and then you pass in the name of the file minus the extension that you want to load in. It loads the runtime version of it, turns it into a texture you can draw on the screen. In the draw call, you draw that texture using sprite batch, which is a class that we'll discuss in a second, and that's it. Now you're drawn. Now you can do that once, you can do it 1,000 times. You can draw a whole bunch of stuff. You can draw 10,000 copies of this if you want to. It's simple. So simple, I'm just going to go ahead and do it right now. All right, this is the Visual Studio 2010 Ultimate Edition, which I'm sure we're all really excited about. But this is also, all of these tools are completely available in the Express Edition, and there's some exciting tool changes coming in the Mango version that are available all the way down in the Express version. The new profiler, which is incredibly exciting. But let's just assume that everything I can do here, you can do as well in any version of Visual Studio 2010 that you have. So, File, New, Project. I'm going to make a Windows Phone game. Call it My Build Shooter. And we'll go ahead and target Windows Phone 7.1. All right. Let's see. Looks like the code's still in a pretty good size. Can folks see this okay? Not too terrible? Yeah? Yeah? Okay. I'm not hearing a whole lot of snoring, so you're awake, right? All right. So I want to zoom in real quick and show you the content project. Let's see. Does this thing work? Whoa! Awesome. All right. So inside the solution that we automatically get, we have the game code and we have our separate content project. This is where all of our assets go. This is where our art goes. So I'm going to go ahead and just, first of all, I'm going to back out of that. And I'm going to go ahead and add some stuff that I have. Inside my art folder, I just have 2 graphics and a sound file. Bloop, they're going in there. Now I'm going to zoom in again. I'm going to have a look real quick. You notice when I click on the player, there's a couple of properties that show up. This is the content pipeline. These extensions that are installed by XNA Game Studio automatically give you the opportunity to process these types of files into runtime formats. By default, it says, oh, this is a PNG. Okay, it's a texture. I know how to handle this. It'll automatically compile it through, spit it out in a runtime version that we can use. And that's great news. We don't really have to do anything special to allow this thing to compile. When I press F5, it'll compile to runtime formats. All we have to do is access it at runtime. So if I wanted to make a player character, there are 2 things that I care about: what he looks like and where he is. So we'll use these runtime formats, Texture 2D and a Vector 2, player texture and player position. Now we can draw something somewhere. It's It's easy enough. Here's the load content method that I was mentioning. Now we have a graphics device. We can begin to load graphical content. We use a content manager. This is how we get at the runtime versions of our content. Player texture equals content.load. Load what type? Load a texture 2D, please. And we pass in player. Why do we do that? Because player.png is converted to this asset name called player. That is the special name that is used to access the runtime version of the asset. Now you can directory the heck out of this. You can put as many subdirectories as you want, and all of those are all of those are honored by the content pipeline. So that's how you can differentiate files with the same name. So if it was in a subdirectory, it'd simply be sub whack whack player. So content load player, got him. We're all set. Now that we have the player graphic, all we have to do is modify the draw call so that we can draw him somewhere. Sprite batch is a class that allows us to do this heavy lifting. We begin a sprite batch call, and here's where we draw all of our sprites. We call sprite batch draw. We draw what? Player texture. Draw where? Player position. And then just for fun, you have a color that you can multiply on top of it. Color white will give you whatever the source color of the graphic was. Sprite batch.end, done. F5. Go ahead and put this little guy on the screen. And there he is. No problem. We have our graphic at 0, 0, drawing at the top of the screen because vector 2 is initialized to 0, 0. And though there isn't anything visible about this, it is actually drawing at 30 frames per second. It's incredibly performant, and it can only go downhill from here. We'll try real hard to keep things as performant as possible. But let's jump in and talk real quick about what it is that we just saw. Drawing in the XNA framework can be split out into two camps, 2D and 3D. They can be interoped all you want, but they are accessed slightly differently. In this talk, we're going to be dealing primarily with 2D graphics, but 3D is also a possibility. In the 2D world, XNA Game Studio is significantly different from XAML and Silverlight. What you're doing in the 2D world in XNA Game Studio is very, very rapidly blitting or filling up the screen buffer with materials from other textures. And that's what Game Studio 2D is all about. It's about blitting textures to the screen as fast as you possibly can. Period. Now, because that's the goal, XNA Game Studio offers you tools to do this very fast and very easy. The first and most important is called Sprite Batch. It's a class that's given to you automatically, and it supports batched rendering of 2D textures. And you have a ton of options. I think there's half a dozen overloads. You use spritebatch.draw and its many, many brothers and sisters to take any source texture you want and blit it to the screen. It has alpha blending support, additive modes. You can rotate, scale, flip. You can blit source rectangles and destination rectangles separately, so this gives you the opportunity to do things like sprite sheets. So this is the heavy lifter for 2D. Now, a combination of this class and the magic of the content pipeline gives you access to a fantastic class called Sprite Font, which allows you to convert a TrueType font into a sprite sheet automatically through the content pipeline, and then use Sprite Batch to blit out any text that you draw into it, and it automatically picks out the right spot of the sprite sheet, kerns it, does all the spacing for you, and then you have very, very fast 2D drawing of text with Sprite Font. So, Sprite Batch, Sprite Font, your two heavy lifters. Now, if folks are looking to get a little bit deeper, and let's say you want to draw 2D primitives, you want lines, you want your lines and your dots and all of your very cool asteroids-ish kind of retro stuff. You can do that with the 3D calls that we have. You can draw 3D primitives in 2D space with XNA Game Studio, and you can have your asteroids game that way. If you are a fan of smooth curves, looking for things like real-time data or smooth sinusoidal things, you might consider Silverlight for that. There are ways to use XNA Game Studio to approximate curves, and there are a number of curve math functions, but the actual drawing of them is not is not something that is XNA's super strong point. So if you absolutely, positively must have those beautiful smooth curves, think Silverlight. What about 3D? As I said, it's a D3D11 API-capable GPU on chassis 1. The actual usage of 3D in XNA Game Studio has been simplified a bit down to 5 configurable effects that you can combine and use to create a variety of effects for your user. The basic effect gives you 3 lights per pixel lighting if you want, and very easy mesh transform, world, view, and perspective transformation. There's dual texture effect for folks that want to burn in their own lighting. So if you have pre-rendered shadow maps or you have pre-burnt-in lighting, you can use dual texture effect. Alpha test effect is how you can simulate a whole bunch of stuff without drawing a whole bunch of polygons. Environment map effect is your bumpy shiny solution. So if you have your hero ship that needs a whole lot of fantastic shiny chrome, that's your environment map effect. And then finally skinned effect for dudes walking around. So that is your arsenal of tools for 3D. A combination of these can yield some very impressive effects, and you can see some of the 3D games that have come out on Windows Phone 7, The Harvest, Hydro Thunder. A lot of great stuff is coming out that uses just these effects. And it does, there is a limitation. The Windows Phone developer ecosystem for games does lack developer programmable shader support, so you cannot program your own HLSL shaders in this model. But you can use these effects, and you can get some tremendous results. All right, we talked about graphics. As I said before, there is no evidence on the screen that I am actually drawing this thing at 30 frames per second. I could just be making all of that up. I want to make sure that we dispel that rumor right now. Let's take some input from the touch surface, use that to move the player around. As if with drawing, the amount of code is pretty minimal. We're going to use the touch panel class to take a free drag gesture and just use that to move the player. Super simple. We enable the touch gestures, then we poll the touch panel on every frame in the update call. We empty that out and use the values that we get back to adjust the player's position based on something called delta, which is something that comes along with every touch registered on the device. So let's just jump right in and do it. We still have our drawing on the screen, and we just have to add input. So the first thing that we do in initialize, we'll add a call to touchPanel.enabledGestures, and we care about the free drag gesture. There's a whole bunch of them. There's horizontal drag, vertical drag, pinch, flick, all that stuff. You can, if you want to, use this. This is a bit mask, so you can OR it with any other gesture that you care about. For now, I only care about free drag. Now that we have the gestures enabled, we can begin to poll the touch panel every frame to figure out if there's been anything going on. So again, update call. We haven't done anything here yet because all we've cared about is drawing. Now we care about update. So, that was neat. While touch panel is gesture available. Now that we've committed ourselves to a potentially infinite while loop, we really need to make sure we clear this out. Gesture sample. GS equals touchPanel.read gesture. Now we have a gesture sample. I'm going to go ahead and just do a simple check. If GS.gestureType equals gestureType free drag, we know it's a gesture we care about. Just in case we decide to change the enabled gestures and are getting multiple types, then we'll go ahead and just move player position plus equal GS.delta. Excellent. All right. Now, it is entirely possible for the user, having his ship over here, to put his finger over here and move the ship. I don't know if I'd call that an exploit, but it certainly looks a little funny. Now, that's because we didn't add any code to discriminate on where the player was touching. We're simply saying, if you move your finger, we'll move the ship. It's a good contract, and we'll honor it. But it serves the purpose well enough. It's moving around. It's great. 30 frames a second. We're rocking and rolling. We'll add a little bit more coming up here, but the input was pretty simple. Let's talk about the options that you have when you're taking input. What you just saw was gesture-based touch through the gesture sample class in the touch panel class. Gesture sample is the easiest way to take and process touch input. All it does is it provides a set of gestures that you can subscribe to, and they are the common ones that you know: free drag, horizontal, vertical drag, pinch, tap, flick, double tap, hold, that kind of thing. You subscribe, and the system will tell you if it detects a gesture of that type. And all of the thresholding, all of the UX, all of that metro experience that comes into what is really a flick, what is really a drag, what is really a pinch, all of that is done and taken care of for you. That means that your game will feel very much like the metro experience on Windows Phone, and this is a great thing. You want your game to play nicely in the ecosystem, and this is why we recommend using gesture-based touch. There's a limitation. It gives you up to 2 touch points because that's the maximum number of fingers that these standard gestures really end up using. There is no currently standard 3-finger gesture for Windows Phone, so up to 2 touch points. If you absolutely, positively, really want more than 2 fingers, you can use raw touch input, and the actual chassis contains a 4-point capacitive touch system on it, which means it can register up to 4 touches at the same time. I have seen a few games use this to interesting effect. 2-player, 2-person, 2-finger air hockey is the interesting one that I remember seeing. But I think you probably have many more ideas in your head about how you could use this. Now, if you use raw touch, you get up to 4 touch points, but you have to do the interpretation yourself. All you're given is, there's a touch there, there's a touch there, there's a touch there. The touches are identified by a unique ID. So, if there's a touch there becomes there's a drag there, it's the same ID, that the finger is tracked. So you can do whatever discrimination that you need to do to make sure that this is the touch we want, that's this user, that's that user. You do have that power, up to 4 touch points with raw touch input, but you lose that sort of automatic UX that's so good about the gesture-based touch. So, stay with gestures unless you absolutely need to go to raw. There is accelerometer input. You subscribe to an event. The event fires back anytime the reading changes. You respond to that. Simple enough. And in OS 7.1, in Mango, there's an optional gyro in the chassis, and there's a motion API that combines a lot of this stuff together so that you can get a much more accurate picture of the device's location, orientation, and space, along with acceleration. So you can use that. Okay, we got something on the screen. We got something moving around. Let's add a bad guy. We have the player moving around on his own volition. We need something that moves on its own, that isn't player controlled. So we will add something fairly basic. It's going to be another texture with another position, and it's going to move according to an incredibly sophisticated sine wave algorithm that I wrote, patent pending, that basically just moves them in a little up and down. You know the term I'm talking about. Yeah, it's one of those. Sorry. And then we'll also use the math classes that are part of the XNA framework to do a very simple collision test. We'll build 2 rectangles, one around the player and one around the enemy. We'll use the internal intersects function that's inside the XNA framework to determine if they're clipping, and if they are, we'll respond because they've hit each other. Simple enough. Let's go ahead and just jump in and get it done. Just like for a player, what do we care about for a bad guy? What it looks like, where it is. We'll need a little bit of extra data here because we're doing some different stuff. We're going to make the player spawn or appear on one side of the screen, fly to the other side, and there are a variety of conditions under which we'd want this enemy to respawn or come back to that side of the screen. So we're going to need to store that initial position. So we'll need an extra variable. Enemy start position. And finally, enemy speed, our first magic number. I think it's our only magic number. But I'm proud of these, love these. They're the heart of every game. And with these 4 items, we have enough to make a bad guy. So let's go ahead and just do it. Enemy texture is really going to end up pretty much the same way as the player texture. We just call it enemy instead. Done. Now that we have a graphics device, we're going to use something that we know about the graphics device to give us some information that will help us spot the enemy in the right place. So enemy start position equals new vector 2, and we'll use the graphics device data to understand where the right side of the screen is. That's going to be the width of the viewport. That's going to be its x value. And then we're going to put it halfway down the screen. So that's going to be the enemy start position. He'll start on the right, and then we want to go ahead and set enemy position equal to enemy start position. There we go. So now that we've loaded him, we'll go ahead and move him, and then we'll finally draw him. Moving the enemy is pretty simple. Every frame will move him by that speed. Enemy position.x minus equals enemy speed. Done. And then this is where my fantastic math skills come into play. We're going to use this sine wave function. Now, let me see. How does this work? It's enemy position.x times enemy speed divided by graphics device.view. I'm just making this up, by the way. Let's see. Times enemy speed times the absolute. Oh, wait. No, I'm done. All right. Now, these are the internal .NET functions that return doubles. Just got to cast it to a float real quick. There we go. Well, that looks smart and fantastic, and that'll get the enemy moving in an interesting way. And then I do care if he ends up on the wrong side of the screen. If he goes off the screen, he shouldn't. So if he goes any less than 0 off the screen, let's go ahead and just set him. Let's just set him right back to where he started. There we go. Finally, we've got to draw him on the screen. We've already got a sprite batch that's locked and loaded, so we'll just keep the party going. Oops. That'd bring the party to a halt pretty quick. Color.white. There we go. Well, this ought to do it. Let's see what happens. All right. Oh, what? Whoa. He's there. I guarantee it. He's just. I got a bug, don't I? I think 6 people answered that question all correctly, by the way. Thank you. I forgot to divide by 2. That's what you meant to say, right? That was what you're telling me? Oh, yeah. Pretty good. Pretty good. Okay. So he's moving, I'm moving. We're not interacting. I can do this all day. Nothing happens because we didn't write any logic to deal with the fact that these 2 things are clipping. We'll do it very simply. We have the technology. Yes, I've waited the entire conference to say that. All right. We'll use the rectangle class. This is something that's part of the XNA framework. It's easy to use. Rectangle player rect equals new rectangle, and we'll use what we already know. We'll use player position.x, player position.y, player texture.width, player texture.height. Excellent. Now that we have the player rectangle, we'll construct a similar one for the enemy. Do I feel lucky? Player enemy. Whoop, 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 whoop. Thank you, Visual Studio. All right. Now that we have the 2 rectangles, all we have to do is if argument out of range exception. Remember your fortune cookie, Charles. If enemy rect intersects player rect, boom! Always comment your code. Then we'll go ahead and set enemy position equals enemy start position. It's an easy way to make sure, it's an easy way to verify that this collision system is working. Oh yeah. Oh yeah. Yeah. Achievement unlocked. All right. So this is why I do this job. I love this. Okay. So the math that you saw wasn't that complicated, but there's a lot more out there that you can use that comes for free in the XNA framework, especially some of this stuff in the motion category. Smooth step, Catmull ROM, Hermite curves. You're going to make better use of this than I ever could, but it's all there for you. So any of your parametric kinds of functions that you do for motion, I'm a huge fan of LERP. In addition to being incredibly fun to say, linear interpolation is a great way to do transitions between things like color values, motion, and so on and so forth. For those that are working in both the 2D and 3D spheres of influence, you have your full vector complements, 2, 3, and 4, points, matrices, and quaternions for your rotations. And then for collision, what you saw was rectangle. There are 3D equivalents, bounding box, sphere, planes, and rays that you can set up and do all of your hit testing in 3D as well as 2D. All of these contain intersects and contains methods. And just as I told you, magic numbers being the heart of any game, the random class definitely deserves a mention. Much fun has been had with randomizing all kinds of things, and I assume that you'll have just as much fun as I've had with that as well. Okay, what's left? Audio. Super simple. 2 lines. You load it in a sound effect, you play it, you're done. Let's do it. I wouldn't go this far and not be able to use my explosion sound. I have to. Sound effect explosion. Cool. We load it up just like we load a texture. Explosion equals content. Again, the content manager is at work here, but we're loading a sound effect this time. Explosion. Thank goodness I commented my code. I know exactly where I'm supposed to put this. Explosion.play. Done. All right. You know what comes next. All right. Thank you. No, really, thank you. You like me. You really like me. So what did we see there? There's a whole lot behind the scenes that's happening that you don't have to worry about. Sound effect and sound effect instance are the 2 very easy ways to play sounds in XNA Game Studio. We use the first one. Sound effect is a fire and forget system. You get one instance, you fire it, you throw it away, it's managed away for you. No problem. Sound effect instance is used anytime you want to have a little bit more granular control over the sound while it's in flight. You can volume change it, you can pitch shift it, you can pause it, resume it, and so on. You choose which one you want to use. Both are essentially brought in the same way through the content pipeline. You did exactly what we saw there. You load the sound effect through the content pipeline, then choose either you want a sound effect or an instance. Both can be loaded as WAV files of PCM or 80 PCM, both supported through the content pipeline. We do recommend if you want compressed sound, 80 PCM is great. Microsoft compression gives you like a 3-to-1 ratio. Asterisk, your mileage may vary. And then the Windows Phone framework can play up to 64 concurrent sounds. Pretty good. You can get a lot of fun stuff going on with 64 sounds at the same time. And as I said earlier in the talk, if you have custom formats, go ahead and extend that content processor and importer. Go ahead. It'll be great. You can extend it to any custom in-house sound format that you've got. Playing music is as simple as using the Windows Phone's Media Player class. It does eat MP3 and WMA files natively. Okay, now the dark arts. Audio the dynamic way. As part of XNA Game Studio 4 and the Windows Phone tools, we extended the sound system to allow something called the dynamic sound effect instance. And what this allows you to do is it allows you to directly manage and twiddle bits of audio. It only allows this in 16-bit PCM. But if you really, really, really want to do DSPs, you want to do bit twiddling, you want to do dynamic audio off the web, this is how you do it. Any synthesized or data-sourced audio can be used through Dynamic Sound Effect Instance. Now, I don't do this, but I know that some folks in here do. And the folks that can actually operate audio at this level, you frighten me. It's so cool, I can't even believe it. But I need to stress, most of you making games are not going to want to use this because not only does it require some restrictions on the type of content that you can use, but there is a processor cost to this because it's giving you lower level access to these buffers. So consider sound effect and sound effect instance to be your heavy lifters, and if you absolutely have to do that weird like dream sequencing program that listens on the microphone and then changes the sounds in your headphones, this is totally the way to do it. I have a great example of gameplay that was done this way. We had an app week a while back where people were creating their own games and so on, and someone challenged the engineer. They said, you can't make a game that's just audio driven. You can't do it. You don't ever tell that to an engineer. Ever. Within like a day, he came back And he says, "Nah, check this out." And he's got a game, and you're a whale, right? You're a whale, like a blue whale. And you're supposed to go, you're singing into the microphone, there's a little female whale, and the better you sing, little hearts come out, and she starts moving towards you. And and if the whales kiss, you win. So, yeah, that was good. That was good fun for a few hours. People outside the conference room were kind of like craning their heads. They didn't know what people were doing in there. It was excellent. But yes, the freedom is there and the power is yours. So use it wisely. All right. So we have a game. That game it's got it all. It's got graphics and it's got input and it's got audio and so on. Now this is a game that you could make easily in Windows Phone Original OS 7.0. What about Mango? What about this new, this updated OS? What do you get as a game developer from moving into this world of Mango? Well, you can see it on the screen. There's a whole bunch of stuff. It's just a mess of stuff. And these are the bits that I consider relevant to game developers. I'm not even listing all the stuff that's there for not just consumers, but app developers as well. Take a look and see some of the things that might be interesting to you. Fast app switching, the XNA Silverlight story, background agents to manage things like music playback and transfer in the background, the Unified Motion API, access to the live camera feed, SQL-CE for all of your RPGs and relational database games, of which I'm sure there are hundreds, literally hundreds. TCP UDP socket connections, so you can do multicast multiplayer over a router if you want to. Tools, a new CPU memory profiler, which is available to you as far down as the Express Edition for free. It's fantastic. Isolated Storage Explorer, which gives you the ability to go, did I really save a file there? Accelerometer and location emulator built in now. You can actually spoof accelerometer changes. You can fake the shake, as they say. And also, 16 new regions in which to sell your games. A marketplace test kit to make sure that you'll pass cert, and an integrated advertising SDK that no longer has to be downloaded separately. Now, we're going to get into a few details about these particular ones, starting with fast app switching and then moving right on to XNA plus Silverlight. Fast app switching is a huge thing. We need to talk about this. In Windows Phone OS 7.0, when your game left focus, it got tombstoned. That meant that it took a while to resume. You'd have to reload everything. In Mango, fast app switching means you do not necessarily get tombstoned. There are circumstances under which your game can very quickly resume itself, and you need to be prepared to respond to those. Let me show you how. Okay, your game is running. It's in the green. Things are great. All of a sudden, your game player gets a phone call. Whoop, deactivated. He goes to the phone. At this point, your game needs to save its state. It gets a message saying, I'm about to be deactivated temporarily. Please save your state. You do so. You're a good citizen. You save the game really quick. Everything gets done. The game is now in a dormant state. Until the user goes back to it, it's not doing anything. The application's phone resources have been detached and all threads and timers are suspended. You don't have to do anything at this stage. You're just waiting for the player to come back. Now, in Mango, when they come back, the operating system, if it hasn't been required to release the resources, keeps them around. As an app developer, you're going to be looking for a flag called isAppInstancePreserved. And in Mango, this flag can be true. And if it's true, you can assume that all the resources that your game was holding prior to deactivation are still there. Your level files, your graphics, your sounds, your data, all of that is still there. By responding to this flag when it's true and choosing a quicker code path that doesn't require that you reload everything, you can make your game players' lives so much better. Because any speed up in a game, even if it comes from the operating system, is something that the gamers will thank you for. They'll go, man, this game is fast. That's what you want. Now, the worst case still can happen. Yes, your game gets dormant, they take a phone call. Then they go play Full House Poker. Then they go play The Harvest. Then they go do all this other stuff that requires a ton of memory. In some cases, your game will get tombstoned. If it gets tombstoned, the resources are detached. You cannot assume that the resources are still yours. How do you know? isAppInstancePreserved will be false. So, in order to be ready for the world of fast app switching, you just need to be responding to this flag and have two code paths, one that loads all the resources again and one that assumes that they're already there. That's what you got to do to be ready for fast app switching. That's the world of Mango. Your customers will thank you for it. All right. Now that we've talked about fast app switching, let's talk about XNA and Silverlight integration. What does it mean to have XNA and Silverlight in the same world together? It means that XNA graphics can live in a Silverlight application. It means that the Silverlight application model now gives you a surface with which to draw on. There's a shared graphics device manager that can change state. When it flips over, it gives access to XNA Game Studio to draw on a surface. Now, folks would say, wait a minute, that's not true integration. You tricked me. Nope. There's a component to this that allows you to draw Silverlight in XNA as well. Putting these two worlds together is not that complicated. In fact, we're going to do it. We're going to work on that together. What you do is in this new world, if you want Silverlight plus XNA interop, you move to the Silverlight application model, draw into the XNA surface, and then if you want Silverlight controls over top, you simply use a class called UI Element Renderer to render Silverlight controls in your XAML right on top of the XNA surface. All the input and all that input processing is automatically handled by Silverlight. All you have to do is tell it what to draw and where. And it's not that tough. We'll go ahead and do it together. But the problem that folks they have is, wait a minute, you just said I have to change my application framework. It's not that hard. Let me show you. At the top of the screen, here's your XNA game loop. This was like 3 billion slides ago, but I thought I'd show you again. Initialize, load content, update, draw, unload content. Very familiar. You know this. You pass. You get an A. What happens is initialize goes away, and there's a direct mapping between the XNA versions of these functions and the new Silverlight versions. Load content becomes on navigated to. Update becomes on update. Draw becomes on draw. Unload content becomes on navigated from. You move your code to these new methods, you get the same thing. You get the same performance, you get the same code calling functionality, that kind of thing. It's pretty simple, pretty easy to do. And inside the onDraw call, if you want to, you can then call the UI Element Renderer to render any Silverlight pieces on top that you want. How hard is this, really? Let's go take a look. So this was our game. You understand the code path. It makes a lot of sense. I'm going to go ahead and open up a version of this that was built for Silverlight. Let's take a look at what's changed. Can I do this? All right. So you'll notice a couple of differences. You'll see that there's a gamepage.xaml and a mainpage.xaml, and gamepage.xaml has its own CS file. It's all very tricky and clever and such. Inside this gamepage.xaml, you will find these classes that we talked about. Here's onNavigated_to. This is your method for getting your content loaded. And you notice we do the same stuff. We load the player texture and the enemy position, and we load the explosion. No problem. Here's onUpdate. We take the same touch gestures, the same enemy position, the same rectangle. There's my same code comment. And then onDraw. Sprite batch begin, draw, end. We've just moved this code into the corresponding functions in the Silverlight model, and we should be good to go. If I press the play button, this is what you get. You get a Silverlight app that launches with a button that says Change to Game Page. By clicking that button, we then get to an XNA surface, and on that surface, there's my game. Right there. All right. That's it. We're in the Silverlight world now. Thank you. I haven't even pulled the rabbit out of the hat yet. Hang on a sec. I'm going to show you the next part. The next part, we're going to go ahead and jump into. Come on, there we go. We're going to jump into adding a little extra data on top and using this UI element renderer, which I think people are interested in. So you know, if you go to mainpage.xaml, you get what you expect. I mean, it's got the Silverlight button, it's got the change to game page thing, it's laid out, there's your XAML stuff. Check out the gamepage.xaml. There isn't really anything there. In fact, the code comment in the XAML tells you, no XAML content is required. The page is rendered entirely with the XNA framework. Thank you, comment. I'm going to go ahead and just kind of go off the wires here and drop a slider in there. There, ha! Take that. No XAML content is required. Now that we have the slider, I'm going to go ahead and make it mean something. Let's go ahead and use this to modify the enemy's speed. Minimum should be, what's my magic number? It was 8. I'll make maximum 10 million. Let's do 25. The 10 million thing I leave as an exercise for the reader. Now that we have this slider, we can interact with it and so on, but we need to render it. It will not render automatically. The Silverlight renderer is disabled by default unless you decide to render this thing yourself. So we're going to do that. I'll show you how. UI element renderer. UI element. There we go. And inside onNavigated2 equals new UI element renderer. We pass in a root element. That's this. That's the Silverlight page that we're on. And then the texture width, you're going to use just the width of the graphics device and the height of the graphics device. All right. While I'm here in the update call, we'll go ahead and do something with this. We'll do something with the slider. So enemy speed equals slider1.value. There we go. And then in the draw call, we simply call every frame, we call UI element.render. And that'll take the current state of all the Silverlight controls in this page, turn it into a texture, and then we'll call spritebatch.draw UI element.texture. Vector2.0, we're drawing at the top left of the screen. Color.white. F5. Oops. Cannot convert double to float. Are you missing a... Yes, I'm missing a cast. Change the game page. There's our slider. Going to go forward. There he goes. Excellent. All right. Silverlight, XNA, together on the screen for the first time. Oh, it feels good. Now, it is a little bit weird. You know, this kind of moves the player and the slider. Ooh. Well, I just found a new game. Yes! All right. All right. But again, that's because of the way this is handled. Input's taken care of for you by Silverlight. You're still processing input manually in XNA. That is something that you'll have to kind of work to deal with. But that's up to you. What now? We've come a long way, baby. We've made a game. It's got all the features. Considerations as you build your game. Considerations as I run out of time. I got 2 minutes left. Let's try to go through it as fast as we can. Okay. Keep your game within memory limits. 90 megabytes max. Don't go over it or your game won't work. There's a garbage collector. This is managed code. It kicks off at every 1 megabyte of allocations. Every time there's a garbage collection kickoff, there's a blip in performance, and your players might notice it. So remember, keep your allocations low. If you have to allocate at the start. Try to force garbage collections at places where users won't notice. At the end or beginning of levels is a great way to go. The more objects that you create and release dynamically, the more churn. There's no way around that. So think about fixed arrays. Think about not using those dynamic lists as much. This is a performance thing. It's important. Folks have heard about a generational garbage collector in Mango. Yes, there is. The 2-generation generational GC. It just means that there are less frequent full collections, but they do still happen. It's not a panacea. Consider fixed arrays. Please avoid using LINQ in high-frequency code. If you're doing any database stuff, please try not to do that with LINQ and high-frequency code. Also, LINQ can inject extension methods into IEnumerable classes. It's very, very sneaky. If you find using system Windows LINQ, just remove it. Just get rid of it. Prefer value types to ref types. All of the XNA framework math types are all value types. They live on the stack, not the heap. So you're safe to instantiate those anytime you want, as much as you want. So never fear about math. Everything else, your mileage may vary. Be careful. Performance and memory profiler. You have this in all versions with Mango tools, including Express. Memory mode to find where your memory is being allocated. Performance mode to find where your CPU is spiking. And as I said, available even on Express. It really is cool. I want you to use that and use it all the time. Marketplace opportunities, you know, I think you've read this in other places. Really simple, $99 a year to join and develop on physical devices. 100 free apps per year, as many paid apps as you want, 70-30 revenue split, all on AppHub at create.msdn.com. Free, paid, trial, and ad-supported. It's all there for you. Here's the one that I wanted to make sure people see. Write this down. If you're a game developer, mobile games at Microsoft.com. This is Microsoft Game Studios, and they are reaching out to developers who are making games to get them involved in the program. You don't need a publisher. If you want to talk to them about games to develop on Windows Phone and you want to be a part of the Xbox Live program, mail mobile games at Microsoft.com. Do not cold pitch. Start with who you are, the games you developed. They will get in touch with you. Then when you have the right paperwork signed, you can discuss your specific game to them. Very, very important that you deal with this the right way. So, with that, there are more samples, resources, white papers, full tutorials, games you can rip apart at AppHub, create.msdn.com/game development. There's a whole Windows Phone game development section there with full video tutorials and all the stuff you could ever possibly want. There's even video tutorials with me, so if you're not sick of me yet, you will be by the time you go to that website. But it's everything you need to get started with Windows Phone. I will be here for questions. Thanks for staying and coming here on a Friday. Thank you so much.